In this lecture, we are going to discuss about phasors and phasor diagrams. Now, the word phasors come from the word phase. Okay, so basically phasor diagrams gives the pictorial representation of the phase relationship between two quantities. All right, so what is a phasor diagram? Or first of all, what is a phasor? A phasor is an anti-clockwise rotating vector. Basically, it is a vector which is rotating anti-clockwise that represents a sinusoidally varying quantity. Now we have seen that in this chapter, the current, the alternating current and alternating EMF, they are sinusoidal in nature. What do I mean when I say sinusoidal in nature? You remember the graph of the alternating current? How does the graph look like? If you plot the graph of current with time, it goes like this, yes or no? This is nothing but a sine wave, okay? Sine wave. So for that reason, we say that the current is sinusoidally varying with time. Not only current, even the EMF is sinusoidally varying with time. So a phasor is an anticlockwise rotating vector that represents a sinusoidally varying quantity. It can be an alternating current or an alternating EMF. Okay. Now this vector is imagined to rotate with angular velocity equal to the angular frequency of that quantity. I believe you remember the expression for the current. How is it expressed? The alternating current here. It is equal to I naught sine omega t. All right. So this vector is rotating with an angular speed omega. Okay, which is equal to the angular frequency of that quantity. Got it? And its length gives the magnitude of that quantity. Now this is the diagram. Okay, we have two vectors here, I naught and E naught. Now you can clearly see here that E naught is larger than I naught. Okay, which means that the magnitude of E naught is larger. And these two vectors, they are rotating in the anti-clockwise direction with an angular speed omega. Is that clear? So basically here you can see that this I naught is rotating faster than, it is rotating before, it is rotating in front of E naught. Obviously both of them are rotating with the same angular speed omega, but then I naught is a little bit ahead of E naught. By how much angle it is ahead? By an angle phi. This is called the phase difference between the two quantities. Okay, so phi here is one, it is the phase difference. All right, so a phasor diagram is very important here in this in the discussion of this topic. Why? Because from here, like I said, we can calculate the phase relationship between the two quantities.